So, the common emitter amplifier circuit that you see on page 1 in figure 1 is built from a voltage divider circuit. Do you see the voltage divider circuit in figure 1? Here's what it looks like. You see, we've analyzed the voltage divider circuit in detail. So basically, you take a voltage divider circuit, which is made up of a voltage divider R1, R2, and then you connect a transistor with an RC and an RE, and that's the voltage divider circuit. Now what we're going to do to this circuit is connect 3 capacitors, okay? So, we're going to connect one capacitor on the input side. This, and we're going to call it C-in. That's where my tiny little signal is going to come in that I want to amplify. So I'll show that as a tiny little signal like this. You see that? Maybe you can't see it way over there because it's tiny. So this is B-in. All right? And it's an AC signal. Voice, radio, TV, sound, it's all analog. It's like an AC signal, right? Fluctuating. So that's the signal that I want to amplify. So it's coming in at this point. You put a capacitor there. We'll call that C-in. On the other side, at the collector, I'm going to connect another capacitor, and I'm going to call this C-out. So if you have the 2 capacitors shown in figure 1, can you label them C-in and C-out? They're labeled right now as C1 and C2. But so that we can associate with the fact that one is on the input side, the other one is on the output side. Okay? So that's C-in and C-out. We're also going to add a 3rd capacitor. Show the 3rd capacitor around RE. Right now, that capacitor is not shown in your figure 1. Can you do that? And we'll call this C bypass. CB, sometimes we'll label CB, B for bypass, okay? So 3 capacitors, C-in, C-out, and C bypass. So by connecting these 3 capacitors around a voltage divider circuit, we now have created a common emitter amplifier circuit. Okay? So this is a common emitter amplifier circuit. So the signal coming out here is going to look, it's going to be reproduced. It's going to be a reproduction of this guy. So it's going to be only bigger in size. You get it? Okay. The thing though, if you look at note number 5, is that the output signal is 180 degrees out of phase with the input. So when the input is going up, the output is going down. That's all it is, okay? But it's still going to be the same signal, only upside down. So if I was to show in the lab, if I'm going to show V-in like with a sine wave from a function generator, which is going to look like this, let's say, right? Then, if this is my V-in, if I was to look at V-out, here's V-out. If I was going to look V-out on a scope, which is what we're going to do, it's going to be the same as that, only bigger in size, but also what? 180 degrees out of phase. What does 180 degree out of phase signal look like? When the input is going up, the output is going down. That's all that means. All right, good. So that's the circuit. With an amplifier circuit of this type, of a transistor type, there's 2 parts to analyzing the circuit. The first part is DC analysis, because there's DC voltage here, okay? Plus VCC is a DC voltage. So the first part of analyzing an amplifier circuit is to do a DC analysis. And the second part is doing what? I've got a small AC signal. So it would be AC analysis. So to keep everything in perspective, there's a note at the bottom of page 1. What does it say? DC voltages and currents will be labeled with uppercase letter of the alphabet. So VB, IB, VC, IC, VE, IE, we have to, if we label it with an uppercase, it means what? DC. And if we want to show an AC voltage or an AC current, because in this circuit, we're going to have both of them present. We're going to have an AC voltage and a DC voltage, an AC base voltage and a DC base voltage, an AC emitter voltage and a DC emitter voltage. Do you see? Because I've got two signals floating around in an amplifier circuit. So that's important. So from now on, when you do homework, when you do questions from the back of the lab, make sure you don't mix uppercase and lowercase. Uppercase will be DC, lowercase will be AC. Make sense? Page 2. Figure 2 shows the fact that we now have an AC signal coming in here, so that AC signal here will cause an AC base current to flow, and that's shown as IB. Do you see IB shown at an angle there, at a 45-degree angle around the Q point? So that is a base current, and it's an AC base current. So do you see how it's labeled with a lowercase b? So that base current will cause, a tiny base current here will cause a large collector current to flow. So the large collector current is shown on the left side there, and it's labeled IC. Do you see that? And those currents are around the Q point. Do you see where the Q point is shown? And about the Q point, you've got IB, and then that IB causes an IC to flow. Because we know that in a transistor, IB causes IC to flow, right? That's the foundation of how transistors work. This IC, that AC signal IC, will now cause a VCE across the transistor, and that is shown at the bottom, VCE. It's a little bit faint, but can you write down lowercase c and lowercase e there, which is my voltage across the transistor?